Good day, class. Our topic of discussion today in physics is the triangle of forces. The triangle of forces says that when a body is in equilibrium under the action of three forces, then the three forces can be represented in magnitude and direction by three sides of a triangle taken in order. This implies that whenever we see a body that is being acted upon by three forces, we can form a triangle from those three forces. We can make those three forces to be in the form of a triangle, and that triangle must be taken in order, which implies we must not change the direction. We must not change the direction of each of the forces acting on the body. Now, if you look critically at this triangle diagram there, we have a body of mass A, a body of mass A given a weight W acting southward. We have the force acting in the west direction, and we have the tension being stretched upward with an angle of inclination theta. Now, if I want to form a triangle from this, I'll have the shape to look like this without changing the directions of the arrow. I repeat, class, the arrow indicates the direction of each of the forces. So we have the force moving in the west direction, we have the weight moving in the south direction, and we have the tension T being stretched upward with an angle of theta. So from there we'll form a triangle. We can apply this formula to solve questions in physics whenever we see that a body is being acted upon by three forces. We can use the triangle of forces to solve questions in physics once we see that a body is acted upon by three forces. So what are the three forces here? We have tension, which is in Newton, we have the weight, which is also in Newton, and we have the force, which is in Newton. So we have three forces. That was why we used the triangle of forces. Now, looking at this question, WAEC 1990, this is the shape given in that year. So we have force, tension, and the mass given as kg, and we know that weight equals mass times g. Take note of that. Weight equals to mass. We're going to be using the 10. We're going to be using 100 because that thing is supposed to be weight, and weight is what now? 10 times 10, because our g is given as what now? 10 meters per second square. Here we also calculate the tension in the string. Because we have three forces here, we have the tension, we have the force, and we have the weight. We can use the triangle of forces, so which implies we'll convert those forces to be in form of a triangle from there without changing the direction of the arrows. So we have the force moving westward direction, we have the weight moving in the south direction, and we have the tension being stretched upward at an angle of 60 degrees. Here we can use any of our acronym SOHCAHTOA to solve a triangle, but here the suitable one will be cos. Why? Because we are given the adjacent and we are asked to find the hypotenuse, which is car. We know the adjacent, we are asked to find the hypotenuse, so we use car. And car means cos equals adjacent all over hypotenuse. So we have cos 60 equals 100 all over t. Cross multiply, we have t cos 60 equals 100. Make t the soluble formula, we have our t equals to 100 over cos 60, and cos 60 equals to 0.5. When we push our calculator, we have our t to be equals to 200 Newton, which implies the tension in the string equals 200 Newton. So I have more questions that I want us to solve in WAEC 1993, 1999, 2000, and nego past question we have 2008. Please get past questions and solve the questions in those given years.